For which values of x the series is a convergent series? You have the summation of x plus 2 to power n. Remind yourselves of geometric series. For a geometric series, remember that the general form is a times r to power n minus 1, and starts from 1, goes to infinity, as long as you have a ratio like r, that absolute value of r is less than 1, or r is bounded between -1 and 1, this guy is convergent to a divided by 1 minus r. Take a look at this series. It follows the same pattern of a geometric series. This is basically the summation of r to power n, and starts from 1, goes to infinity, but here you have a variable like x. So the ratio is x plus 2. Following general form of a geometric series, as long as the absolute value of r, which is absolute value of x plus 2, is less than 1, we have a convergent series. Okay, now let's do a little bit of algebra, everybody. Absolute value of x plus 2 is less than 1. It means that x plus 2 is bounded between -1 and 1. Subtract 3 from all sides. Subtract 2 from all sides, you get -3. On the other side, I gave you the answer. So your x is bounded between -3 and -1. So as long as your x is bounded between -3 and -1, then the series is convergent to. So as long as my x is bounded between -3 and -1, the series x plus 2 to power n, and starts from 1, goes to infinity, is convergent to a divided by 1 minus r. But what is your a in this case, right? Your a is basically x plus 2. So let us write this guy down with a different color. You get x plus 2 divided by 1 minus r, but r is equal to x plus 2 as well. So let us simplify it now. This becomes x plus 2 divided by 1 minus x minus 2, or x plus 2 divided by -x minus 1. So let's write this, summarize this. In conclusion, the power series, or the series of x plus 2 to power n, and starts from 1, goes to infinity, as long as x is bounded between -3 and -1, is convergent to function x plus 2 divided by -x minus 1. We can look at the terms of this series as well. Check the terms. Your series is x plus 2 to power n, and starts from 1, goes to infinity. So if I plug in 1 for n, when n is equal to 1, what do I get? I get x plus 2. Plus, when n is equal to 2, I get x plus 1, sorry, x plus 2 to power 2. Plus, when n is equal to 3, what do I get? I get x plus 2 to power 3 plus the rest of the terms, right? So, what's happening here? If I write these terms in expanded form, I have x plus 2 plus x squared plus 2x plus 4 plus, now here you just need to multiply these together to get a polynomial, or you can follow the formula. Here you have x cubed. Let me write this guy down for you here. If you have a plus b to power 3, if you don't remember the formula, it is a plus b to the second times a plus b, which is a squared plus 2ab plus b squared times a plus b. If you do the distribution, you get a cubed plus 2a squared b plus ab squared plus, you get b cubed plus 2ab squared plus ba squared. So basically, if you combine this together, you get a cubed plus 3a squared b plus 3ab squared plus b cubed. You either memorize the formula or just multiply a binomial and this quadratic expression here. So let's see, let us copy this guy down here and continue. So you get x cubed plus 3x squared times 2, which is basically is 6. So you have 6x squared and then you have 3 times 4, which is 12x, and then plus 2 to power 3, which is 8, plus the rest of the terms. Don't forget to add the rest of the terms. So this power series is convergent to x plus 2 divided by negative x minus 1, as long as x is bounded between negative 3 and negative 1. So this is your takeaway from solving this problem. Let's take a look at decimals and show you what you have. So let me change this. You have 2x plus, sorry, x plus 2 divided by, let me put it in parentheses to avoid any confusion, divided by negative x minus 1. This is your rational function that you see, and then let us copy down the terms of the series x plus 2 plus x squared plus 2x plus 4 plus x cubed plus 6 times x squared. So as you can see, I'm keep adding these terms, plus 12x plus 8 plus, you can add more terms if you want to. You must get x to the 4th because you're eventually raising these to power 4 plus the rest of the terms, right? You get, now let's see, 6x cubed. So this guy guaranteed that as long as you are between -3 and -1, the graph approaches x+2 divided by -x+5. You can add more terms as well, everybody, right? If you raise these to more exponents, to more powers, you end up with more odd powers, more even powers. So by taking a close look at this, for now, we see that as long as we're close to -3 and -1, the graph approaching this function. So this is the basics of power series, helping us to approximate complicated or complex functions.